Okay, so good afternoon, everyone. Yes, this is me. I'm Karl König Königsson, and I guess that the big question is, of course, this one. Why are we here? That is a philosophical question, of course. One could think in the wider perspectives, and the nerd reply would probably be 42. But Daria replied that, or Daria said this morning, and I thought that was a good point, that we both BSI and Mimer are trying to help open VMS users to protect and realize the full value of their application investments, end quote. And that is definitely our goal. And the goal, the things that I'm going to talk about today is our migration toolkit, how to get from point A to point B, that is how to get from RDB into Mimer. Well, that is a good question. So, as I said, I can only guess what are your pain points. Well, I guess that you are worried about Oracle and where Oracle is going with RDB. That could definitely be one of the reasons that you are here. Another could be that you are thinking about how to modernize your toolchain, how to use modern languages, for instance, then take Rust or Java or ADU.NET to access your data on OpenVMS. Or basically, you're just interested in how to move to x86 since Itanium is going the way of the dodo. And the point of all is, of course, that you would like to do this without doing major brain surgery on your code base. My proposal, of course, is using my Mimer SQL, and this is where it comes into place. The point is, when we look at the future-proof part, Mimer is an actively based application. We are working on OpenVMS. We've done that since donkey's years. We started there. That is where this product was born, and we've used it for every version since. And the point is, we use the same database as the code base for all our platforms. So hence the multi-platform part, we have supports them for clients on Windows, on Linux, on Mac OS, on basically, well, anything. We have a lot of operating system support. And when it comes to x86, we've been there from the start. I would say we had the beta up and running and for example, publicly available in March 2023, and our production release was in October 2024. And to this, I would like to add just the added bonus on that this is a system that is unencumbered by third-party software, and it's built and maintained wholly within the EU. That means if there are any geopolitical advantages or disadvantages that might come into play, we are not really bothered about that. So that is, I think, could be of use for somebody somewhere. But yeah, Mimer SQL, this migration toolkit, that's what we're going to talk about. And the point here is that in this sense, we have two DCL scripts that we work with, but let's do it this way. I'm going to show you how this thing works. And let's now pray to the demigods, because this is the scary part. Here we go. So, how does this migration work? Well, the point is, this is now OpenVMS and x86 I have running on my machine. For obvious reasons, I can't show you how I do the export from the RDB on Itanium here. But the point is, we have a script. The script uses the RMU utilities from RDB and extracts the schema and all the tables as text files. So let's do this. This is my migration directory. This is the migration toolkit. It consists of these files, more or less. This is an early version. But the point is, you see, I have my loadmimer.com and I have my unloadrdb.com. So I have used the unload RDB previously. And I will now cheat and use that. I have a zip file of this extraction. This expands into subdirectory in my migration directory. And it then, here it goes, looks something like this. So I have then, as I said, one text file per table. And I also got my schema here. So let's use this I will now load this schema using this utility, the load Mimer utility we have. The point here, well worth thinking of, is in RDB is a database that's the large container that contains all the tables. So we have mapped this to a schema instead. So you have one Mimer database that contains many schemas. And I will now import this database called CRM. And using these two, the first one is the username, that one is password. So this script sets up the schema, it sets up the user that can access this schema, and it then reads and applies the schema that I exported. So the first thing it does is translating the schema, going through with our translation tool, going through the schema and fiddling with it. So it's whatever stands there that is RDB that needs to be mapped to Mimer is read down to Mimer, and it applies the schema. And for an encore, so to speak, it also does an analysis of the database. It optimizes it in ways, for instance, looking at if there are superfluous indices and things that we can get rid of. So now I loaded my schema. It's time to look at this. What did I do? Okay, we got, I could log in using my user. That's a good start. Let's just see how many tables we loaded. Okay, I got 158. That's a good thing. Let's see what we can do with this. It's time to load the data. And I'm going to do the same thing here. I'm using the same command, the load Mimer command, using my password. So in essence, I'm just telling this script to use whatever I set up, the empty database. It's time to populate it. So we now go through all the text files in the export directory and import them into Mimer. Right. And the last part here, of course, now I've got my data, I moved everything. Of course, I want to show you then how to use this. So what I've done is I have a small application, and this is part of a proof of concept that we've done. So I have a few COBOL files here with embedded COBOL. Sorry, with embedded SQL, the COBOL files. So what I'm going to do is take one of them, and I'm going to build that one. It's called the PRC, it doesn't matter, but that's one of the files. And this one is now, as you can see, converted. So what I did, I took the COBOL file from my RDB system. This was verbatimly copied from the Itanium system running RDB to my machine here, and I run the tooling on it. So right now, it just created an extra file, another file, a converted file, and it has converted that one and built it, and now I can run it. So this is data from the source system with a COBOL file from the source system, and well, you can see that it runs. Well, let's go back to my presentation, shall we? So what was this? As I said, this is a proof of concept. And we've been working together with a Chilean company on ARS. This is a Mexican company. They're called Profuturo. And Profuturo is something they call an Afore. An Afore is Administradora de Fondos para el Retiro. That are private entities in Mexico that manages all the pensions, the workers' retirement savings accounts. And Profuturo is started in 1997, and it's today the third largest Afore in Mexico, and it has a savings portfolio of roughly $70 million US dollars. And as I said, we've been working with ARS, and ARS is led by Don Fernando Roja, who is sitting there on the third row from the bottom. And so please bother him if you have any questions. So, and what is this? Yes, as I said, this is a large pension company. So of course, this is a huge database. As I said, there's 158 tables, and I couldn't import those. I mean, I imported all the tables, so the table structure is there, but all the data would be a bit of a bother because we're talking hundreds of millions of rows of data. So that would take quite long. But the point is, and there are thousands of programs, so quite a lot to do. But the point what I wanted to show it was how I did it, that we could do this at a scale. And that is exactly what we are doing right now with Don Fernando, is this migration. So let me break down the demo. What did I do? So we start with this. I showed you the structure I had in my file system. And so prior, as I said, prior to the conference, we had extracted all the data from this database at Tierra. And as you remember, my first step was to run this unload command. I unloaded my zip file archive, and that is the database. So this is the content I showed you briefly. And so I said every database is then converted to a schema. So this is the point. I have the schema here. I showed you that one. And that is the one we ran the translator on. We do that once. So the point is it gets converted and put in a parallel directory. So this is the result file. If there are any things, part of this translation that for any reason does not really work, there could be a construct that we haven't seen, where the point is you will then iterate over this file, and by using that then force it into Mimer, get things done, get it working. And so that's sort of the point. So that's the idea. All of this is you start with something, you convert it, and then there's an iteration. So the next thing is, here we've got that schema. So the next I mentioned also was that we create an analysis file. That's the point we use in one of our tools. Once you loaded the database schema, this is part of the standard Mimer toolkit, doing analysis, trying to see what sort of optimization we can do. And that is also in this directory. As I said, everything that is exported, we don't touch anything. That directory unload data is exactly as it was from the original export. That's the point. Then the last thing I started filling was this COBOL file, and I made a secondary directory for this. I made this one. I had this POC directory with all the COBOL files, and I then converted this one, and using this build POC script. So it created first that's the SQL file, the embedded SQL file. We used then our tooling, and then I ended up with the COBOL file, which I then run through the ordinary compiler, linker, and get my executable. And that was sort of the last step of my demo. Let me break down this slightly more. This was a bit an overview. So now you saw what I did in the demo and what different parts. This migration, this is a crucial part. What exactly is it that we are doing when we do the migration? The first thing is trying to export things. We translate it and we apply it. So what is the export? I mentioned that we use the RMU utility. This is the standard RDB utility for extracting, in this case, the schema. So once I got my schema, I then start to do something else. I start to export all the data. Again, it ends up in text files. I specify here what kind of delimiters I use for the different columns. And that was it. That was, in essence, what the unload script does. There's no magic there at all. Now comes the fun part. This is when I call load Mimer and use the create command. So it calls our SQL translator. And that you say, I say what kind of source file do we have? In this case, I use it for a script. That is, I translate an SQL script into something that would be understandable by Mimer. And so you see the in file is the RDB file, and the out file in this case is the Mimer schema. So I didn't do anything. The thing is, Mimer did this. And as I said, there are some proprietary extensions to RDB's SQL, and that is handled as much as we can. Mimer is very standards compliant. So for most of the time, I would say, with our work with the translator, we run through the schema without any problems at all. But as I said, there is an iterative step to it. So just edit the schema and do the translation again. And after a while, you will see that, okay, now we've got something that works. And if you try this, please do let us know if you find any things any hiccups, because we want to add those to our tooling. Of course, the point is that this should be a painless experience. It should just work. But it's very hard for us to foresee every sort of weird situation. But that was that, okay? What goes on? The next step, I read it in using our batch SQL command. So that was how I applied the schema. And yeah, that was it. Running also, of course, the output from the analysis, the optimization. That's the last part. That was sort of into detail what the load Mimer does for the create. Now comes the migration of the code. Same thing here. I started with an export. I copied this file, my source code COBOL with embedded SQL from my integrity system, or sorry, my Itanium system. And I run it through the translator again. So here I can use, as I said, I got my RDB, I say it's COBOL. And just to show a little bit how this works, what we do. So this is a diff between the original file, the source code file, the original from the Itanium system, that's on the left-hand side. On the right, you see the output from the translator. So what we've done is we try to fiddle as little as possible. We add things, but we also add comments. You will see what we did. So just look into some of the details, what we can do. In this case, it's a matter of a translation that is supported by, that's a statement that's supported. We don't do anything. It just works. So that's one of the things. We just said it is supported. The second is to start to translate things. Okay, so this is the source code line, what we got and how we converted it. And the last thing we also do is we can say that this is not supported. This is a construct in RDB that is not applicable to Mimer. So hence we don't use it. But we say that it's unsupported. And that means unsupported. Mimer doesn't support it. It's not interesting for us. So this was sort of an overview of the different things you would find typically in your source code after the translation. This is all there to help you with this. As I said, it's an iterative process. There might be things you have to consider, but you will always find markers that says what we did and why. And worth pointing out, of course, that this translator, it works on C, it works on COBOL, it works on Fortran, and we got even support for modular SQL. So this is embedded SQL, modular SQL. And also note that this format is terminal. We do also support this obscure format called ANSI. I don't know if there are any COBOL heads. I have just recently learned about the difference between ANSI and terminal. And yeah, that's interesting. Sorry, but I digress. That was that part, running it. We run it through the SQL program. That's part of the Mimer distribution. That's what takes the embedded SQL COBOL and translates it into a proper COBOL program. And valid there, as I said, that's COBOL Fortran C we have for that. And the result is this COBOL program that we then ran and compiled. That was it. And why do I do this? What's the whole point? Well, this is the part I really like, to be honest. Okay, I'm biased because I work for the company, but the point is you can move from RDB to Mimer in a stepwise manner. You don't have to do a big bang move. This is the nice part. So the point is everything I now showed you, all the programs, everything runs on Itanium as well as it runs on x86. We have the same tooling everywhere. So that means, of course, if I start with a system where I had my database like this, I've got my legacy application, I'm running it on RDB, and I can then start at my own leisure fiddling with this. So I can start by then translating, fiddling with the data, moving the data to Mimer in this case, and still have my legacy applications running. Now comes the clever part. If I do this, I can then say, okay, I've got the migration working, and I can now work on my source code and see if I can get my applications working. Still everything is running as I want. Once I have established that I got everything up and running, I can do the switch. And I do the switch on the same machine. So I got my RDB there, but I don't use it anymore. So my legacy applications are running on the same system. I not changed anything, still the same applications. And then comes the nice part. I can then move the things. I can move my legacy application. I can start fiddling with them on the x86, still running in my Itanium. So I can verify that they all work on my x86, which they should, because they are exactly the same. But once I've done that, okay, then I can just copy my files. And this is the clever part here. Mimer is binary compatible when it comes to the database file formats. So I can just copy everything. I take my database, I bring up one server, I copy all the files over to x86, start Mimer, and watch your uncle. Everything is running. So that means I have my application running, and the move is done. Then, of course, I might happen to find something in the nooks or crannies of my system, some sort of batch file that just happened to be there. And well, then I can just convert that. And the point with Mimer is, of course, it's very, very easy to point from one server to another. So that means while I still have everything back on my Itanium system, I can just say, okay, whatever you do, whenever you access the Mimer system that I set up, do it remotely. And it just works. So this was annoyingly quick, I can see that. But there was a request for some questions, so that's good. So this is it. You see, the migration toolkit we have is there. It's there for trying. If you want to do a proof of concept, just talk to us. One thing that is worth pointing out is I mentioned Itanium and I mentioned x86. There is a possibility to get this working on alpha as well. The same source code, that's the point with Mimer. We have the same source code for everything we do. So that means, given enough incentive, we could build an alpha version of our current version of Mimer, but we don't offer that. If you look at the website, you will find OpenVMS, you will find Linux, Windows, Mac OS, QNX, I guess, Android, a few things. But that's worth pointing out. So, and the thing is, if you want to do this, if you want this toolkit, please use this QR code. This will lead you to a feedback form. And let us know if you have any thoughts, any ideas. And if you want to try this out, and we can do that together. Proof of concept is definitely something we would love to do. With that, sounds like I have got some time left. Please, any questions? I do hope. Yes.
How would you handle the indexes, and especially the hash indexing RDB?
Bengt, you have to help me out with this.
We translate to, we don't have specifically a hash index, but we translate the hash index to an index.
Okay. Yeah. Don't you lose much performance on that?
No, we've actually seen very good results in moving between the two systems. It's about faster. Are we allowed to say this? They pick two of their most difficult cases in this tension application. And that this is a typical concept running code. And one of these difficult areas took 18 minutes with RDB. And we translated the system and ran it with Mimer, and it took 3 weeks. And they were very happy with this, and they would that is with the indexing. The nice thing with the indexing is that Mimer and RDB are not exactly the same on indexing. So one step that Karl actually left out here is we run the analyzing again, and it will kind of clean up the index for you. So if you have, for example, a primary key and a unique key that overlap, it will remove one. So that actually also done as part of the spreadsheet.
Yes, because you are very close to it with the mean primary key index.
But not now we're not allowed that. We're not allowed to switch. But if you have a unique index in RDB and you have not null on your column, it will switch it to a primary key within that.
The hash index are always unique.
Yeah.
Thank you.
Okay.
So as you can tell, Bengt is one of the people who wrote this thing, so it's very good to have him here as a backup. Thank you, Bengt. Anything else? In that case, I thank you for your time, and yeah.